Hello, welcome back. Now we are going to see about Spark. So what is Spark? So Spark is a fast and general engine for large-scale data processing. And it's an open source cluster computing program. And Spark is used for an end-to-end analytics platform. MapReduce has got some limitations. Say for some computations you have to write a very big code, and sometimes MapReduce will also be slightly slow. But whereas Spark actually overcomes the limitations of what MapReduce or Hadoop has. It can perform operations nearly 100 times faster than MapReduce. How is it possible? It's possible. It's because Spark is having the information on the memory, so which helps to do the data processing faster. And another one thing is also it is using a DAG engine, that is a directed acyclic graph. That is, whenever you're giving command to the Spark, it's not an immediately be compiling it. It will take all the commands and then before you're executing it, whenever you give the command, it is putting a plan which will have the optimized way of doing that particular operation. So because of this DAG engine, it is able to process the data also faster. So this is also one of the advantage over the MapReduce. And the other thing is MapReduce can work only on HDFS file system, whereas Spark can work on any files. The files can be in a cloud, or the files can be in any other operating system, or the files can be in HDFS. That's one of the beauty of the Spark, where the file can be in its own system, and we can get the data and process it. How it is possible, we'll see in the preceding slide. So it is supporting both the batch, interactive, and the iterative analytics platform. And Spark has provided both Scala, Java, and Python APIs too. So when you can use Spark, the Spark can be used for the data integration. It can also be used as an ETL tool, and it is used for the analytics engine also. And high performance batch computation also Spark can be used. And it can also be used for a machine learning and advanced analytics and real-time stream processing also. Spark, just like Kafka or Flume, it also can do the real-time stream processing. And what are the practical applications? There are various applications are there. Some to mention, the credit card fraud detection can also be done through Spark. And the network intrusion reduction, advertisement targeting. These are some of the example applications of Spark. And then we'll see about the Spark overflow. So how we will be doing it? So we will be loading the data from the source. The source can be anything. It can be the real-time sources, or it can be NoSQL database, it can be HDFS, or it can be a RDBS database, or it can be a file in the cloud. And then once the data is loaded from the source, then we transform the data. So, and we filter the data, clean the data, and we kind of enhance the data. After that enhancement of the data is then the process the data can be stored wherever you wanted to store it. Then take this process the data and do the interactive analytics to get the new insights out of the data. And after they've got that analytics, interactive analytics, then it can also be passed to the machine learning algorithms, and you can get more insights. And both the interactive analysis also can give some insights, and the machine learning also gives some insights. From these insights, you can do the actions which will benefit the business. So this is the entire Spark workflow. Now, seeing about the Spark framework, let us come from the bottom, where it has got the storage. As I've already mentioned, it can take the file from NoSQL or the RDBMS, or from the cloud, or from the HDFS, or from the local, any operating system database. Then it has got a resource management. The resource management, so it can have its own Spark scheduler, which says to whom the work needs to be done, or it can work on a Mesos, or it can work on the Yarn also. Then you have the Spark core engine. So on top with which is doing all the Spark core actions. On top of it, you have the Spark SQL libraries, which will be doing actions similar to what Hive does. Then you have the streaming libraries which can do operations similar to Flume or Kafka. Then you have the graphics which can be used for the visualization after you do the interactive analysis. Or it can graphics library can help you to put the graphical representation of the interactive analytics, whatever you have done, which can give a good more insights about the data. And then we have the machine learning libraries which help you to do more analytics and machine learning algorithms. And another one beautiful thing in the Spark is the programming language. You can use Spark using Scala, or you can use Spark using Python, or using R, or Java, or any other custom languages can also be configured to use for the Spark. This defines the entire framework of Spark. Okay, I mentioned it like, see, the data can be in cloud, or the data can be in a RDBMS, or the data can be in the HDFS, or the data can be in a Hive, or in any other database. The data can be in any other system. Still, you can take the data from the different systems, and then you can combine those data, and then you can get more insights. How is it possible that the data can be in different systems, resident on the different systems, still you will be able to do it? That is possible because using the RDD. RDD is nothing but the resilient distributed data sets. This data set is kind of like a framework kind of a thing, data framework kind of a thing. Where, for example, you can take the data from the local system, create a resilient, or you can take the data from the cloud and create a RDD. You can take the data from the HDFS and create an RDD. So RDD1, RDD2, and RDD3. These three RDDs can talk to each other, and you can combine those three RDDs and get new insights. That is one of the powerful thing of a Spark. That's what Spark is built around RDD. You can create, transform, analyze, and store RDD in the Spark program. And this data sets can be partitioned and distributed across multiple nodes. See, earlier, like we were using RDDs, now in the latest Spark, instead of RDD, we can create data frames. So data frame is also similar to RDD, where data frames have got more flexibility than the RDD, where between the data frames, so you can create the data frames from different multiple data sources, and the data frames can communicate to each other, and then so that you can combine the data which are there in the data frames, and then you can get new insights or new analytics can be done on those data frames. So in this way, you need not have to have the data. For example, if I want to analyze on the data, you need not have to want the data to be in one place. The data can be resident in their own native places, where Spark engine can take the data, create the data frames. The data frames can communicate between each other, or you can combine the data, you can filter the data, you can manipulate the data, you can enhance the data, and from there you can get the new insights of the data. So coming to this architecture, Spark architecture, how it is, you have the master node, and then you have the cluster manager, and you have the worker node. What does the master node does? The master node is the one like which gives the work to the worker nodes, and inside which you have the driver program, Spark driver program, and what it is doing. The main executable program that the Spark operations are performed, and the driver program runs in the master node, and it controls and coordinates all the operations, and each driver program execution is a job. And in that you have the Spark context, you have the Spark context, you have the SQL context, which is the program which will be, and this driver accesses the Spark functionality through your Spark context object, represents a connection, and used to build the RDDs and works with the cluster manager. It manages and executors running on the worker nodes. It is the one which is splitting the job as parallel tasks and executes them on the worker nodes, and it collects the results and presents them to the driver program. And from the driver program, it can be taken out and stored in a file, or you can do further manipulations of the data. So this is about the simple introduction about the Spark. In the next session, we'll see the demo of the Spark. Now that I'm not representing the entire command framework of the Spark, a few simple examples of the Spark, which we'll be seeing in the next session. Thank you. Bye.